Welcome everyone. So first of all, let's review what we learned in the last lecture. So last lecture, we learned about at first the AC signal. So we found out that AC signal, which means alternating current signal. So which means the value of the voltage or the current is changing with time. So some points the current is flowing in one direction and some other point current will be flowing in the opposite direction. So the simplest way to represent with this curve, so which is essentially it's a sine curve. And in that we found out there are two half cycles. So one of them is positive half cycle where all the value of voltage is positive, or I can say is Vi is greater than 0. And there is another, it's a negative half cycle. All the value of the signal is negative. So I can write as Vi minus Vi is less than 0. Okay. The sine wave, if you consider only one time periods, so because it is enough for us to consider one time period only to describe the signal, and the time period is t. So between if t is greater than 0, less than t by 2, we have Vi greater than 0, and we call it positive half cycle. And t is less than t by 2, greater than t by 2 and less than t, we find Vi is negative, less than 0, we call it negative half cycle. And mathematically it can be expressed as Vm sine 2 pi ft. Now we use this signal to build the circuit as a signal source. So in this circuit, we first of all we learned what happens if we apply the voltage, apply the signals to a circuit which consists of a diode and a resistor, and consider that is ideal. So we found out this is our input signal. The positive half cycle, negative half cycle, 0 to t by 2 and t. So between 0 and 2 t by 2 is positive. Vi is greater than 0. And we found the diode is forward biased. So in that case, when the diode is forward biased, diode is on, we can replace the diode with 0.7. So we replace the diode with 0.7 and we found out V0, which is the voltage across the resistor, which is Vi minus 0.7 when the diode is on. And when the diode is off, V0 is equal to 0. Similarly, when it's negative half cycle, so we found out for negative polarity changes. So applying Vp minus Vn rule, so we find out that diode is off. When the diode is off, current is 0 and V0 is equal to 0. So this way, if we draw the output signal, we're going to find, see, sorry. So peak is Vm minus 0.7. So we found out that the circuit which consists of a diode and a resistor in series only allows the positive half cycle to pass through in this particular circuit, and it blocks the negative half cycle. So that means it is no longer an AC signal. At the source, it has direction both in positive direction as well as negative direction, but when it is at the output, it's only in one direction. So that we call it rectifier, and it is called half wave rectifier because only half cycle is rectified. This half and this half is rectified, not this half. So half wave rectifier. And we found out the V average, this average value is running somewhere in between, and it is Vm minus 0.7 divided by pi and reflects 0.318 Vm minus 0.7. Here Vm is the amplitude of the signal. So this is the average value of the signal. So that is our half wave rectifier, which converts AC signal to DC signal. So although the DC signal that we see, it's not the type of DC signal that we are used to it every day. Thank you.